All right, these are your notes on networks. And networks are a little different. This is something that's added in there. It really doesn't have much to do with the other stuff in the chapter. It's something completely different. So we're going to go through vocabulary here, and then in class next time we're going to expand on that vocabulary and talk about what they mean, to determine if stuff is traceable, which is one of your vocab words, or an Euler trail, or an Euler cycle, or circuit. Those are your vocabulary words today in this video. So you need to make sure you bring questions to class next time over what these words mean, because we're going to jump right in and going to go through examples. Okay? We're going to start with network. Network is our first vocabulary word. And what a network is an array of nodes and edges, or we could say points connected by lines. And those lines, they could be curved, they could be straight, they could be squiggles. Doesn't really matter. They could go around and form a circle. But we have points that are connected by lines. And those points have specific names. Those points are called nodes. Okay, the points in a network are called the nodes. And you may hear them called vertices. It's the same thing. Okay, but if we look at our example over here, there's a node, there's a node, there's a node, there's a node. There are 4 nodes in this example. Okay, there are 4 points, and those points are connected by the lines. Now we're going to skip down and we're going to go to edges real quick. Edges are the lines that connect nodes. Okay? The lines that connect nodes are edges, and they could be curved. They could be straight. You usually don't see any squiggly lines, but they could be squiggles, I suppose, as long as it's something connecting 2 nodes. Okay? Those are what the edges are. The reason we did edges first is because it tells you whether a node is even or odd, which are our next 2 words here. Now remember, the nodes are points. And an even node has an even number of edges coming from it. So if we look at our picture up here, this node here has an edge going that direction and an edge going that direction. It has 2 edges coming out of it, which would mean this is an even node. And it's even because 2 is an even number. It has 2 edges coming out. 2 is even. It's an even node. An odd node has an odd number of edges coming out of it. Okay, so if we look at this node, it's got 1 going this way, 1 going across, and then 1 going down. It has 3 edges coming from it. So this one is odd. Okay, has 3 lines coming from that point. It's an odd node because odd is a 3 number. And that's what it means to be even and odd. This one here, I want you to pause this, see if you can figure out what it is. The last 2, see if you can figure out what they are, even or odd. This one here and this one here. Go ahead and pause the pen, cast the video, and see if you can figure it out on your own. Alright, this one here is an even, because it has 2 edges coming from it. And then this node over here is odd. 1 is an odd number. Okay, it has 1 line coming out of it, 1's an odd number, so it's an odd node. And that's what it means to be even or odd. Okay, again, let's recap all of that because it's important. Nodes are the points. They may be called vertices. An even node has an even number of lines coming out of it, point with an even number. Odd is a point with an odd number of lines coming out of it. And edges are the lines that come from the nodes, come from the points. And they could be curved, straight lines, they could be squiggles. Don't see squiggles that often, but they could happen. Okay? But that's what nodes, edges, even, and odd in a network are. Those are your first 5 vocabulary words. Now these next 3 build on what those mean. And you'll see a pattern. We'll talk about a pattern in class next time. But they build, traceable, Euler trail, and Euler cycle, build on those 5 vocabulary words at the top. So you really have to know those 5 in order to get the next part. Traceable means that you can go through a network and I spelled through wrong, go through a network touching or crossing each edge once. Okay, what that means is that if I started a node at a point, I can work my way through the network, through all of the points and lines, so that I cross every edge once. I cross every line once. I can't go back across a line. That's what it means to be traceable. Now, I could visit a node. I could go to a node several times. Doesn't have anything to do with the nodes. It does have to do with the edges, though. You can only cross each edge once. And if you can do that, then it's traceable. If you cross an edge twice, then it's not traceable. Now, two vocabulary words here. Euler, and it's pronounced Euler. I'm going to write Euler out over here. The E-U-L-E-R is pronounced Euler. And Euler was someone, mathematician, who did a lot of work on networks. He's got a lot of network theory. But his name is pronounced Euler, not Euler, Euler. Okay? Euler trail and an Euler cycle. Now, an Euler trail happens if it's traceable, but you end and start at different points. Okay? And I've given you an example over here. In this example, we have 4 nodes, 4 edges. And we can start here, and we can work our way around so that we touch each edge once. We cross this one first, this one second, this one third, this one fourth. We've crossed each edge once. Now, we did visit this node twice, which is okay. That's fine, but we want to check and see if we can cross each edge once. That's what it means to be traceable. And then to be an Euler trail, we started at this point, but we ended at a different one. We started here, but we ended over here. We started and ended at different points. That's an Euler trail. An Euler cycle or an Euler circuit is traceable, but you end and start at the same place. Okay? End and start at the same place. So I could really pick any of these corners. We're going to start here, and we would go around the square. And in order to touch all 4 edges, we start and end at the same spot. Okay, we did this one first, second, third, fourth, but we ended at the same point we started at. That makes it an Euler cycle or an Euler circuit. You'll hear both. Okay, so an Euler trail starts and ends at different points. An Euler cycle, you start and end at the same point, the same place. But they have to be traceable first. If it's not traceable, then it can't be those two things. So you have to test and see if it's traceable first, which may just take some trial and error on your part. Okay, we've got 3 examples down here before we finish this video, and the directions say to give the number of nodes and edges for each network, determine if it is traceable, and write yes or no. I'm going to go through the nodes and edges part with you, and then I want you to practice these at home and see if you can figure out whether they are traceable or not, and come to class with those 3 answers next time. Okay, just 3 yes/no answers that you have to do on your own. So go ahead, we're going to pause it. I'm going to see if you can do the nodes and edges on your own. It's pretty simple, but I want to see if you can count it on your own. So go ahead and pause it, do all 3 examples rather, and then see if you can come back and check your answers and make sure you got it right. Alright, let's look at example 1 here. Let's start with nodes. Okay, we want to count the points. So there's 1, 2, 3, 4. So there are 4 nodes here. If you got that right, good for you. Edges, those are the lines that connect the nodes. And there is 1, 2, 3, 4. Okay, so 4 edges also, 4 and 4. If you got both of those, great. Let's go on to the next one. If you didn't get those, go back and see if you understand why you got it wrong. Okay, nodes, remember, are the points. Edges are the lines. Second one here is a little tricky. Okay, there is a node here in the middle. So let's start with nodes. There are 5 nodes in this picture. 1, 2, 3, 4, 5. 5 separate nodes. And now all of them are even. I didn't ask you to determine if they were even or odd, but all of them are even. This number 1 here has 2 lines coming out. Number 3 has 2. Number 4 has 2. Number 5 has 2. And then number 2 in the middle there has 4 lines coming out. So they're all even. All even nodes. But let's count the edges. And where people usually get confused is in the middle part here. Because, let's do these two. There's one, there's two edges. But this is an edge, and this is an edge. They're both edges because they're separated by that node. There's that node in the middle. Anytime the lines cross, usually that means that there's a node there and that you would count them as two separate edges. Now, don't take that as fact because it just depends on who wrote the test and what the problem expects you to do. Here, though, there is a node there, so they're two separate edges. So far we have 4, and then we would have 5, 6. There are 6 edges here. Okay? And that is something that usually catches people, so pay attention to that. Last one, there are 5 nodes, and there are 1, 2, 3, 4 edges on the outside, and then 4 edges in the middle, so there are 8 edges total. If you got all those right, I do want you to come up with answers for whether they are traceable or not. So you need to go back, and I'm not going to tell you those in the video, I'm going to tell you those in class next time. See if you can work your way through touching each edge only once. And it may take some trial and error on your part, but you need to figure that out on your own. So make sure that you do that. Okay, those of you that don't always watch the video, you may miss this, so make sure that you go back and do that. Make sure that you write yes or no, because I didn't give you the answers. And those are your notes for networks. In class, we will extend on this, we'll expand, but those are your basic notes, vocabulary for networks. Bring questions to class next time, and make sure you do those 3 examples at the bottom.